On the second objective here, we're going to use this thing called the Rational Zero Theorem to help us find some possible zeros for a polynomial function. So since this has rational zeros in it, it probably has something to do with rational numbers. If you take a look over here on the right-hand side of the picture here, I got P over Q, rational numbers. They can be written as fractions where the numbers in the fractions are integers. So here, this time I have in the image, I've got some sand dunes that make these really nice, smooth little curves. And that's exactly what polynomial graphs will do. And then I threw in an axis, like an x-axis, because we're finding zeros. Zeros happen at the x-axis usually. Okay, so I'm going to change this up just a little bit. Watch, watch. Boom. So over there, if you see on the left-hand side, my numbers turn to 1 over 3, an example of a rational number. And maybe I have a 0 at, say, 1/3. All right, I'm going to start by doing something we did in the first objective. And what you got to realize is that I'm not always going to be given a 0. So in this case, I'm given f of 7 equals 0. In other words, 7 is a 0. What we're trying to do is figure out a way to figure out where do I start if I don't have that 0. So that's what this exercise is about. Okay, so this 7, we're going to put outside the little box, do some synthetic division. We should get 0 as our remainder. Check to see if you're missing anything. Nah.
All right, so I've got 10, and then negative 81, 71, and 42. Bring down my 10, multiply, 70, add this, negative 11, multiply, negative 77, add negative 6, multiply, negative 42. Excellent.
This means that we have done it correctly. What I have left over here, 10x squared minus 11x minus 6, I'm going to try to factor that thing. Okay, so let's open up our parentheses here. All right. Got to multiply up to 10x squared. Let's just try. Just try 2x and 5x. Who knows if they're going to work? Whatever, just try it. And then the last terms have to multiply up to a negative 6. How about a 2 and a 3? I'm not going to put the 2 with the 2. I'll put 3 here and a 2 there. Now let's do the rainbow. Let's do the inside and the outside terms. Here you got 15, and here you have 4. So 15x and 4x. Can you do anything to get 11, negative 11? Sure, if this is a negative 15 and a positive 4, negative 15, that means that 3 is negative, 2 is positive. There we go. All right, so now listing out our zeros, we get x equals 7, and then we get x equals 3/2 from that parenthesis, and then from the other one, 2/5. Whoops, negative 2/5. Got to subtract it over. So here's our answers. Now we're going to do something with those answers just a second here, so take a look. So writing each of the zeros that we just had as rational numbers, it looks like this. So ordinarily you wouldn't write 7 over 1, you would just write 7. But it's still a rational number if you think of it as 7 over 1. Okay, now here's something else. Take a look at all of the numerators. Numerators, I've got a 7, I've got a 3, and I've got a 2. All of those things are factors of 42, which is the constant term. If you multiply 7 times 3 times 2, you get 42. Okay? Now look at all of the denominators, the numbers on the bottom. So I've got a 1 and a 2 and a 5. Those are all factors of 10, the leading coefficient. And this is exactly, if I multiply 1 times 2 times 5, of course I get 10. And this is exactly what this thing called the Rational Zero Theorem is going to say. That all of our zeros, the top numbers are going to be factors of, let me pull up this pen, the top numbers are all going to be factors of the constant term, and the bottom numbers down here are always going to be factors of the leading coefficient. So here is the Rational Zero Theorem. You have yourself a polynomial. What you have to get from this generic polynomial is that the purple term up here is the leading coefficient. The green one is the constant term. Okay, So what this theorem is saying is that every single rational zero, I'm going to underline that, rational zero, takes this form. It's a rational number, p over q, where p, that number p, is just simply a factor of the constant term. And q is some factor of the leading coefficient. That's what that's saying. Okay, now, couple of things. Since this is only about getting rational zeros, it will not work for irrational numbers. The only way that we can get the irrational ones is if we are either completing the square using the quadratic formula. So it won't work on those, and it will not work on, say, imaginary ones. Again, the only way I can do that quadratic formula or complete the square. So let me put a big box around this and go, no, that doesn't work. Okay. The other thing is that whenever you're checking these factors, you have to realize they can be both positive or negative. You have to check both of them sometimes. Okay, so let me give you a way to help you remember the order of these factors. Now, whenever I go back to this, well, just think about it. What did I say was going on top? Is it supposed to be a factor of the constant over the leading coefficient, or is it leading coefficient over constant, right? When you're taking a test, how are you going to remember it? So let me put it in a way that will help you remember this. Let's look at a very, very simple function. It's a linear function, y equals 6x minus 10. Okay? So let's say we wanted to find the zeros, so we let y equals 0. Right? What's the next thing I would do to solve that equation? I would add the 10 over. So let's do it. Add the 10 over. Now I would divide by the 6 and then reduce it. So notice that what I did over there is I got the 10, which was the constant term, over to the other side of the equation, and I divided by what was in front of the x. I divided by the leading coefficient. The 5 there is a factor of the constant term 10, and the 3 is a factor of the leading coefficient 6. So, best way to remember this is just right here. Whenever you go to solve an equation as simple as this, and each one of your zeros are a linear term, the things that are in parentheses, you would subtract over the constant term, and then you would divide by the leading coefficient. So the leading coefficient is always the one that's on bottom. All right. So let's apply this just to come up with a list of possibilities. What are the possible zeros, rational zeros, based on that rational zero theorem? So for this first one, what we got to do is we have to look at this negative 6 here. And I want to find factors of that. So I'm going to call that one C, right? It's the constant term. We'll call it C. So what are all the factors of C? Well, I know 1 goes into it, 2 goes into it, 3 goes into it, and 6 goes into it. And what I would want you to do is make sure that you put those in order so that once you reach the end, you know you're done. Okay, but there's one thing I forgot about this. I need up front here a plus or minus, because it could be a positive 1 or a negative 1, positive 2 or negative 2. Now I'm going to do the same thing with this leading coefficient here, which is a 1. This is my A equals. So my A, well, 1, only factors are plus or minus 1. Okay, so according to the rational zero theorem, what I do is I just divide these two things out. I need C divided by A. Subtract over the constant term, divide by the leading coefficient. So basically, I got plus or minus, well, if I take 1 divided by 1, it's going to be 1. 2 divided by 1, 3 divided by 1, 6 divided by 1. I've got the possibilities 1, 2, 3, and 6. And that's it. How many possibilities are there? There are 8. You might think that's quite a bit, but there's a whole bunch of numbers, right? There's a whole bunch of numbers. Only 8 possible ones could be zeros of that function. All right, let's look at number 2. Number 2 gets a little bit more complicated because the leading coefficient is not a 1. So, just like I did before, my constant term here 8 constant terms. So let's list out factors in order, plus or minus 1, 2, 4, and 8. Okay, and then for my leading coefficient here, a, list out all of those factors, and it's 2. This is going to be 1 and 2 because it's a prime number, plus or minus 1 and 2. Okay, so again, whenever I list out my possibilities, it is the constant terms divided by the leading coefficient factors. So it's a C over an A. Should be equal to, don't forget your plus or your minus. Now if I take each one of these 1, 2, 4, and 8 and divide them by 1, I just get them back. So plus or minus 1, 2, 4, and 8. Okay, now, so I've done this one. Now I've got to divide them all by 2. So 1/2, 2 over 2, 4 over 2, and 8 over 2. But some of these are in the list twice. 1/2 is not, but 2 over 2 is the same thing as 1, so get rid of it. 4 over 2 is the same thing as 2. I already have it in the list, get rid of it. 8 over 2 is the same thing as 4, which is already in the list, so get rid of it. So here's our list. This time I've got 1, 2, 3, 4, 5, so times 2, I've got 10 possibilities. Okay, so I have 10 things that could possibly be zeros for this function. So here's the next question. Okay, so those are possibilities. What do I do with them now? How do I check to see if one of those is actually 0? So that's exactly what we did in the previous objective. We used the factor theorem. We're going to do synthetic division with those numbers, and we check to see if the remainder is 0. If it is, it must have been a factor. So that summarizes this right here on this last exercise. Once you've applied the rational zero theorem to get that list, like we've done on both of these cases, how do we tell from that list which ones we get to use as zeros? And the answer is synthetic division. And what do I want from synthetic division? I want the remainder to equal 0. Because when it does, it's a 0 of the function, and that's a factor. Okay? So that's exactly what this is saying. This last one, verifying these zeros, we're going to verify if it is a 0 from that list that we came up with using synthetic division. And then you're going to use the factor theorem after you've gotten one factor to help you factor the rest of it. Okay, so that's all the theory behind this objective. Check out the video on the exercises so you can practice them just a little bit. And right here, that wraps it up. Objective 1 was about finding zeros of a polynomial. We were given one of the zeros up front, and then we used synthetic division to divide it out, and then was able to factor the rest. How do I get one of those zeros if I'm not given one to begin with? I'm going to use that rational zero theorem, where I'm taking a factor of the constant term divided by a factor of the leading coefficient, and then I'm doing that by synthetic division, check to see if the remainder is 0. If it is, that must have been a 0. Okay, so here's your assignment, and I'll see you in the lessons, and then also our exercises, and then also back in class. All right.